When thinking about soil and its properties, the main things scientists think about are its texture and acidity. Soil texture is determined by the relative proportion of inorganic materials, such as mineral particles. So it's the relative amount of sand, silt, and clay. Those are the three major mineral particles that are present in soil. Sand, it ranges from a size of 2 millimeters to about 0.05 millimeters. If it's smaller than that, it's characterized as silt. Now, silt is just basically the same thing, only in a much smaller particle. And silt goes from about 0.05 millimeters down to about 0.002 millimeters. Anything less than that would be characterized as clay. So clay is actually really small mineral particles that are all packed together. A soil's texture, it can affect the properties of the soil, and then in turn it can influence plant growth and what types of plants are able to grow there. They're also important in determining the characteristics of soil because many of the different particles have different properties associated with them. Clay is considered probably the most influential of the particles because it is important in determining many soil characteristics. The reason that it's able to do that is because of its high surface area, meaning that area like you would calculate in math of the outside of the particle is really high. So it's greater in smaller particles than it is in larger particles. We would say that their surface area to volume ratio is very big because for the size of the particle, it has a very large amount of space on its outside. Soil minerals are often present in charged forms or ions. Each particle of clay, as you can see, it's negatively charged around the outside, and those positively charged metallic ions, such as magnesium and potassium, they'll all adhere to the edge of the particle of clay due to the interaction of the negatively charged clay and the positively charged ion, while negatively charged ions are held in place due to the interaction due to water. However, that interaction is much weaker, and therefore it's more likely that negative ions are going to not stay present in the soil for very long. Generally speaking, the larger soil particles provide structural support and determine the permeability of the soil, while these smaller particles of clay, they're actually responsible for holding nutrients and water within the soil. Here's a table of just like different properties of soil and what happens in different soil texture types. In terms of aeration, sandy soil has a lot of air and it drains very quickly, but it's very bad at holding nutrients or water. It's easily worked. Loam, which is considered an ideal agricultural soil, has good aeration and good drainage, meaning that lots of water can get through it and there's lots of water present, and it's pretty decent at holding minerals and water. Clay is very poor in aeration. There's not a lot of air present in clay just because the particles are so small. And because those particles are so small and packed together, it has poor drainage, but it's really good at holding on to those nutrient minerals, and it also has a high capacity to hold water. Soil acidity is another major characteristic of soil. A soil's acidity is measured on the pH scale, which is a scale that ranges from 0 to 14, with 0 and lower numbers representing more acidic values, and then higher numbers representing more alkaline or more basic solutions. So 7 in the middle would roughly be neutral. Water is most typically at a neutral pH of 7. Soil pH affects plant properties because the solubility of certain nutrients varies depending upon the soil. So, depending on if the soil is very basic or very acidic, it will influence how nutrients are held within the soil. An acidic soil has reduced ability to bind positively charged ions, so those positively charged mineral ions won't be held as easily in highly acidic soil. So nutrients such as potassium, magnesium, they'll quickly be leached through these more acidic soils. So most soil, it falls within the range of around 4 to 8, so it's more common than not that it's going to be acidic as opposed to being basic. So on to the major soil types. Spotto soil, it's an evergreen forest. It has a layer of acidic litter. It has a thin or absent ahorizon. The acidic qualities of the litter, what happens is there's a high degree of leaching, and yeah. With alfisol, it's a temperate deciduous forest. It's usually common in humid climates with hot summers and cold winters. We would be characterized as that type of area. And it has leaves and twigs make up much of its O horizon. Its A horizon is rich in accumulated humus, has a light colored E horizon, and its B horizon is thick and rich clay. With mollisol is found in a temperate grassland, so this would be more of the plains region, and it has a thick, dark A horizon that is rich in humus, and then a calcium carbonate rich B horizon. The aridosol, that's common in deserts or other dry or arid climates, it has a layer of pebbles on the surface. It's obviously characterized by large amounts of sand. It has a thin brown A horizon and then a light brown B horizon that has a large degree of salt and carbonate and gypsum. Oxysol, this is common in tropical areas, so this would be present in your tropical rainforest. There's little or no leaf litter accumulation, mainly due to the high rate of decomposition that's present in tropical regions. It also has a acidic A horizon that's rich in humus and a thick B horizon that's heavily leached due to the acidic qualities of the soil.